Boom. Welcome back to Physical Science Online Edition. This is actually my third time redoing this video, so if this one doesn't work, I'm just going to kind of give up and it might be mismatched. So, parallel and series lab. What you got in here is we have an amp meter. In class, you would normally have a voltmeter, but instead I'm just going to, for time's sake, tell you that the voltage of a D-cell battery, which is what is hooked up here, is 1.5 volts. That will stay constant since your power source is staying constant. In class, you would start out by just making sure a light bulb lights up. That means your circuit is working. And also, this one light bulb is going to be your control today. So you're going to kind of compare everything else to one light bulb all by itself, hooked up to my amp meter, which I have hooked up to the 1 amp reading. So if you can see at home, I know it's really hard to. We're reading the top numbers, which means that my little red indicator is exactly at 0.1 amps right now. 0.1 amps with one light bulb. Then we'll move into lab. So you already have the one light bulb. It does ask you to do no light bulb. So here's the empty wire. Just did the connection between them. That's at 0.7 amps. Then it asks you to start putting light bulbs in series. These are actually made ahead of time for you. So they're just kind of right in series. Series means in a row. Series means that there's only one path the electricity can take. And you can see it got a lot dimmer. And we went down to 0.02468. 0.08 with 2 light bulbs in a row in series. 3 in series. If you need to pause at any point to write these down, go ahead and do so. I can just barely see the light. It's just barely on with 3 in series. 0.246, 0.06 amps with 3 in a row. 4 in a row. So I'm kind of just Frankensteining them together at this point, just making sure that the wires touch. I can't even see a light on, but it does say that some amperage is going through there. 0.05 amps. 0.05 amps with 4. And then lastly, 5. Like I said, I'm not even able to see the light at this point, but there is 0.04 amps going through 5 in series. At this point, you should pause the video, do your math, and do your reflection questions for lights in series before moving on to the parallel circuits section, which I'll demo in just a second. So pause it, and we're back. So parallel means that the electricity has 2 different or more. It can go any which way, 2 or more paths. It can go either direction. So soldering them together means that it can go through either light bulb equally. And that's what parallel means. You're still using your 0.1 amps for the single light bulb, just as your control. And then 2 light bulbs in parallel, you can see that that's very bright. And my amperage has gone up to 0.2 amps with 2 light bulbs in parallel. Then I'll up it again to 3 light bulbs in parallel. 3 light bulbs in parallel. Once again, very bright. And we're up to 0.3 amps with 3 in parallel. Let's see if I can get 4 in parallel. So this is where it gets kind of interesting, trying to create these contraptions when you're in person. It's kind of fun. 0.34 I got for a little second there. 0.34 amps with 4 in parallel. And then 5 is really, really tough. Let's see if we can do this though. 5 is really, really tough to get that all to hold so that the electricity can choose any path it wants to. That's what we're trying to do here. I'm not getting that one to work just quite right. But let's just, for your data for the video, we'll say that it is 0.4 amps with 5 in parallel. And that'll be your data. You should be able to finish out the lab and do your reflection questions based on that. So 3rd time was the charm. Thanks for watching. Do feel free to rewatch or pause or ask questions as needed. Have a good day.